Hello kids, today we're going to continue with section 1.1, which is functions and function notation. I need to make sure that you understand how to use function notation and understand the meaning of functions. This is why I am not going to start a new section today. Plus we'll have new kids joining today, so please make sure you understand function notation and what it means to be a function and how to evaluate functions. So we're going to start off with the learning targets. I can identify the domain and the range of a relation and functions, and I can evaluate functions. Okay, so a set of ordered pairs is called a relation. And you can have a set of ordered pairs like this one right here. So remember, an ordered pair is XY, so maybe we can put that. Ordered pair is your XY, your coordinate pair. Or you can have a mapping. So this is a set, this is a map. And so you're mapping the 4 to -2, the 10 to 8, the -3 to -5. So we have different representations of a relation, okay? So you can either represent it as an ordered pair, 1, 2, -2, 4, 0, -3. You can put it in a table, okay? So you still have 1, 2, -2, 4, 0, -3. You can put them as points on a graph, and then you can map them. So those are the 4 ways that you can represent a relation, okay? And remember that you have inputs and outputs. Always think about inputs and outputs, okay? So in an ordered pair, you have input and then output. So this is your X and this is your Y. So then input and output, okay? So let's take a look at the domain. The domain of a relation is the set of all X values. So for example, the domain for this set of ordered pairs, you got to use set notation, are your X's. So 1, -2, 0. And then the range of a relation is a set of all Y values, which are the Y parts, 2, 4, -3. Okay, so a function, we talked about it yesterday, a function is a relation in which input X domain has only one output. That's very important. And the way that you can see it when you look at a table or even a graph, the X values cannot repeat. Now the Y values can, but not the X's. Okay. So then there are special notations to indicate a function. So you can use f of x, g of x, and h of x. Now a function notation is just a more specific way of naming y, okay? So all of these equal your y value. They equal your output. And then your X in here, that's your input. Okay, and it's true for all of these as well. Now we talked about using the vertical line test. So we need a spaghetti to do this. So let's see what the vertical line tests for a function. If any vertical line intersects the graph in more than one point, the graph does not define y as a function of x, okay? So remember, this is your x, this is your y. So if I put a spaghetti, vertical spaghetti, okay, then you're going to see that it only touches at one point or intersects this parabola only at one point. Wherever you put this spaghetti, it will just intersect that one point. So then this is a function. Okay, now the domain for this is all real numbers, okay? So we're going to use set notation from negative infinity to positive infinity. So that means all real numbers. The range, so the range always goes from the bottom to the top. So way down here, this spaghetti does not touch the parabola, but it does start touching it right there, which is, ooh, I cannot see my eyes here. So let's see, this is 1, this is 2. So it starts from 2, and it's a close bracket because the spaghetti does actually touch the vertex right there. And then it continues to positive infinity. Okay. So now, the function, is this a function? So we have to look at our x's. 1, 3, 4, 5. Do the x's repeat? No. So that means it is a function. The domain are just your x values. So 1, 3, 4, 5. 1, 3, 4, 5. The range are your y values. So 2, 4, 5, and 5. But we only put 5 one time. You don't need to put it twice. So 2, 4, and 5. Okay, so this is your input, and this is your output. Is this a function? So Tom is going out with Yvonne, Luis is going out with Yvonne, Irvin's going out with Robin, and Mark is going out with Ansha. Okay, so yes. So you see that these x values are inputs. So Tom is not going with 2 people, Luis is not going out with 2 people, Irvin's not going out, and Mark, they're all going out just with 1 person. Now the domain is going to be Tom, Luis, Irvin, and Mark. The range are your outputs. So Yvonne, Nina, Robin, and Ansha. Okay, here are examples of non-functions. So notice that -2 is going out with 2 numbers. It's going out with 4. So this is your input, output. -2 is going out with 4, and it's going out with 0. So this is not a function. So you say no right there. Is that a function? No, it's not. The domain, -2, -1, 0, 1. Remember, we go from least to greatest when you're writing the domain or the range. So the range, the smallest number is 0. And then we have 1, 2, 3, and 4. Okay. So let's take a look at the set. So you have -1 right there, 2, 2, -3. Oops, the x's repeat, so this is not a function. Okay, now the domain are your x values. So -3 is the smallest one, then it's -1, and then 2 and 2, well, you don't have to repeat it, you just write it once. The range are your y values. 5, 5, 4, and 1. Which one's smaller? 1. Then 4 and 5 repeat, so you just write it down once. Okay, so now, the function, is this a function? So notice that this is a circle, and a circle will be intersecting this vertical spaghetti twice, so this is not a function. Now the domain are your x values. That means it goes across the x, okay? So you start right here at -2, and your circle continues all the way to positive 2. So that means you're going to have negative 2, positive 2. The range, you always start from the bottom up. You always go from least to biggest. So negative 2 to positive 2. So negative 2 to positive 2. We're going to talk about the range and domain more tomorrow when we get into section 1.2. Okay? This is just a little taste of domain and range. Okay, so now I want you guys to try these on your own, and we will get back to that. Okay, so this is good for you guys to try on your own. Okay, then we're going to do evaluating functions. So I am going to need line paper for that, but let's start with the first one. Example 1, f of x is equal to 4x squared plus 2. So we're going to do f of 2. That means I'm going to plug in a 2 right there, plus 2. So then that's 4. Remember, order of operations, you do exponents first, so 2 squared is 4, plus 2. And then you multiply, that's 16 plus 2, which is 18. Okay, now f of a. F of a, you're going to just plug in the a into the x squared. So that's going to be replacing it. And so you are done right there. That's your f of a. And then we are going to do f of x plus h. So I am going to use... Actually, I'm going to use the back of this paper. And what I'm going to do right here is I'm going to plug in all of this into the x squared. So you're going to have 4. So you're doing f of x plus h. Sorry. So you're going to do 4, and in parentheses squared, that's where you put the x plus h. So then we're going to know that this is multiplied twice. Okay, so x plus h squared means x plus h times x plus h. So what we have to do is we got to FOIL first. Before we distribute that, we got to FOIL first. So that's x squared plus xh plus xh plus h times h is h squared, and then plus 2 out here. Okay, so now we're just going to combine those two. So that's going to be 2xh plus h squared plus 2. Then I'm going to distribute that. That's going to be 4x squared plus 4 times 2 is 8xh plus h squared plus 2. So then this is your final output. Okay, let's go to example 2. Example 2, we're going to have, oh, this is a G. Okay, so example 2, we're going to have g of x is equal to 3x minus 5. We're going to find g of negative 2, g of a, and then g of a plus h. So I can find g of negative 2 on here. That's just plugging in the negative 2 in for the x. So that's negative 6 minus 5. That's negative 11. And then the a, so g of a is going to be 3a minus 5. And so that's your final output. And then we're going to do g of a plus h. Sorry for the typo. I thought I had fixed it. Anyhow, we're going to do g of a plus h. That's going to be 3 times a plus h minus 5. So that's going to be 3a plus 3h minus 5. And that's going to be your final output there. Okay, let's now some of you guys are having an issue doing this example, these type of examples yesterday on the assignment. So remember, this is your input. Okay, you want to find your output, your y value. the y value. So right now you have -1 and you got to find the y. So you know your x, you want to find the y. So then on the x-axis, you go to -1. So here's -1, and then you need the y value, which is 2. Because you go -1 on the x, and then 1, 2 on the y. So that point right there is -1, 2. So same thing for this, so this is -2. So there's two ways you can write it, function notation or ordered pair notation. So we want the y value right here. So we know 0, and we want this part, okay? So we're going to go 0, and then we go up 3. So it's this point right there, which is 3. So f of 0 is equal to 3. F of 1, so that means when x is 1, so here's 1, you go up 3. So that's 3. And then f of 3, so then 1, 2, 3, and then you're going to go up here, but that's an open circle, so you don't want that point. You're going to go all the way where it's bubbled in, which is 1, 2, 3, 4. So then at 4. Okay? So that's how you do that with those. And then you can also have a table where you can evaluate so you can either have a graph, you can evaluate by plugging into this is algebraically, this is graphically evaluating, and then this is tabular with a table. So is the table a function? So none of the x's repeat, so then yes, it's a function. Give the domain, so the domain are your x values, -5, -3, -1, 1, 3, 5. Give the range. Now we're going to start with the smallest number. The smallest number is -2, and it's repeated twice, so we only write it once. And then 8, it's repeated twice, but we only write it once. And then 11 and 23. Okay, now find f of -3. So that's your input. So this is your input right here. Input, output. So we're looking at -3, the x value at -3. Oh, right here. What's the output? 8. So remember, you can also write it as a point. Okay, then you want f of 5. So you go to 5 right here, and the output is 23. So you can also write it as 5, 23. Okay. Then we want to find, so this is where a couple of you guys were having a little bit of an issue. We want to find this number where the function is at -2. So then we're looking at the y's over here. Well, there's 2 at -1 and 1. So -1 and +1. So you have 2 points. At -1, it's 2. And at 1, it's also 2. Okay. Then right here, that's your output. So on your output table or column, here's 11. So then the input has to be 3. So then 3, 11. Okay. And I think that's it. Yeah. Okay, have a good day, but there's another one where we're going to do the difference quotient note. So go to that one.